If the Earth was flat, it would change everything we thought we knew about our planet and its place in the universe. The concept of a flat Earth challenges our understanding of gravity, the behavior of fluids, and even the way we perceive the world around us. As a child, I had always been fascinated by the shape of the Earth. While most people saw it as an oblate spheroid, a slightly flattened sphere, my parents had instilled in me a curiosity about the flat Earth theory. It wasn't until I was older that I stumbled upon a documentary series on the topic, which sparked a desire to learn more. The idea of a flat Earth might seem absurd at first, but it's actually an interesting thought experiment. If the Earth were indeed flat, several phenomena would be explained differently than we do today. One such phenomenon is gravity. On an oblate spheroid Earth, our mass warps spacetime, creating gravitational forces that pull us towards its center. However, if the Earth were flat, these same forces wouldn't work in the same way. In theory, objects on a flat Earth would roll off the edge, as there's no central point to pull them towards. To compensate for this lack of gravity, scientists would have developed alternative explanations. One possible explanation is that objects on a flat Earth are held back by some sort of invisible force field. This could be an electromagnetic field generated by all living things, or even an energy emitted from the ground itself. Another phenomenon affected by a flat Earth is ocean currents. On our oblate spheroid Earth, warm water is denser than cold water and tends to sink towards the center of the planet. However, if the Earth were flat, these currents would behave differently. Warm water on a flat Earth might flow inwards, creating large whirlpools that could affect global weather patterns. To understand ocean currents better, scientists studying a flat Earth would rely heavily on observation and experimentation. They'd need to study ocean waves, currents, and eddies closely to better comprehend how these phenomena work within the constraints of a flat world. The concept of a flat Earth also affects our understanding of time zones. If the Earth were flat, different regions would experience different day-night cycles due to their unique locations relative to a fixed point on the surface. Let's call it the pole. This would mean that our modern system of dividing the world into 24 time zones relies heavily on our oblate spheroid understanding. Instead, scientists studying a flat Earth might propose alternative systems. One such possibility is based on sun time, where local solar times are used to determine standard clocks for different regions. This could be especially useful in regions far from any major time zone centers, like the South Pole or other remote locations. Lastly, let's consider the concept of global weather patterns and how they'd be affected by a flat Earth. On our oblate spheroid Earth, large-scale circulation systems drive global climate patterns. However, if the Earth were flat, weather might behave differently as well. Global wind currents would play a much larger role in shaping local climates. Warm air near lower latitudes on a flat Earth could rise and move towards higher latitudes, while cold air at high latitudes moves downwards. This unique combination of warm and cold air masses creates large temperature differences between different regions of the world. Theories suggest that these global wind currents would be driven by the Coriolis force, an apparent deflection of moving objects from their intended path when viewed in a rotating frame. On a flat Earth, this effect could have been misunderstood as gravity or other forces not present on our oblate spheroid world. Theorists and scientists studying a flat Earth would need to study global wind patterns carefully to understand these effects better. This might involve conducting research at different latitudes to better comprehend how the unique combination of air masses influences weather patterns worldwide. However, this is where it gets really interesting. Our scientific understanding of phenomena like global wind currents begins to break down on a flat Earth. Our modern understanding relies heavily on complex models and computer simulations that take into account various forces acting upon our world. If we consider a flat Earth, these same models may no longer apply. In fact, scientists studying a flat Earth might need to develop entirely new methods of observation and data collection, in order to make accurate predictions about global wind patterns. This could involve the development of advanced weather satellites capable of detecting subtle changes in air pressure that signal shifts in global wind patterns. Our modern understanding of atmospheric science also relies heavily on an understanding of thermodynamics, as it relates to the Earth's heat engine, a device or system that converts thermal energy into mechanical or electrical work. On our oblate spheroid Earth, this process is driven by solar radiation and greenhouse gases in our atmosphere. However, if we consider a flat Earth, the same principles of thermodynamics wouldn't apply. The Earth's heat engine relies on its rotation to generate kinetic energy that drives atmospheric circulation patterns. If we remove this driving force, the Earth's rotation, our modern understanding of thermodynamics would need to be drastically revised. By examining phenomena like global wind currents, ocean currents, and weather patterns, scientists studying a flat Earth can gain valuable insights into the natural world around us. These studies could lead to new discoveries that change how we understand various forces acting upon our planet. While it may seem counterintuitive at first, exploring alternative scenarios with a flat Earth can actually help deepen our understanding of the world as it is, by making us consider the many nuances and complexities within our current scientific understanding. The study of phenomena like global wind currents, ocean currents, and weather patterns on a flat Earth would require new methods of observation and data collection. This could involve developing advanced weather satellites capable of detecting subtle changes in air pressure that signal shifts in global wind patterns. These alternative perspectives can lead to new discoveries that change how we understand various forces acting upon our planet. The study of phenomena like global wind currents, ocean currents, and weather patterns on a flat Earth can deepen our understanding of the world as it is by making us consider the many nuances and complexities within our current scientific understanding. If you were thinking about visiting Mars one day, a journey that would take several years, even with modern propulsion technologies, the implications of a flat Earth could be quite different. On an oblate spheroid Earth, space agencies like NASA have sent robotic missions to the Red Planet, which are designed to search for signs of life and understand geological processes. However, if we consider a flat Earth, such missions would need to be significantly revised in terms of design and mission objectives. Instead of searching for signs of life or studying geological processes, Martian missions might focus on understanding how fluids behave on the surface of Mars, which could lead to new insights into the planet's past climate. The study of phenomena like global wind currents, ocean currents, and weather patterns would be equally important in a flat Earth context. This is because Mars' atmosphere plays a crucial role in shaping its climate, just as our atmosphere does on Earth. Understanding how Martian winds behave can help scientists better comprehend the climate on the Red Planet. This could involve studying the planet's magnetosphere, which affects atmospheric gases and influences global weather patterns. The study of phenomena like global wind currents, ocean currents, and weather patterns would be equally important in a flat Earth context. By examining these different areas of research, we can gain valuable insights into the natural world around us, even if it means changing our current scientific understanding. In this way, exploring alternative scenarios with a flat Earth can deepen our understanding of the world as it is by making us consider the many nuances and complexities within our current scientific understanding.